I hope you're all having a great day. I am Mr. Ish. Thank you for joining me. In this video, we have a very interesting question here. We have a certain cube which has sides having the dimensions s, as you see right here. We have to find the length of the longest internal diagonal that you can draw within that cube and the angle marked theta, which I will show you in this picture I'm about to draw. Start with a cube, we're looking at that, and the longest diagonal that you can draw in this cube, you have to find the dimensions of that and the angle that comes about it. If you're looking at this cube, the longest diagonal you can draw is the one you can draw internally to this cube. You would be looking at something which will extend across that face, then it would cut across right over here, and then you'd have your longest diagonal forming. It would come from this corner right here to this corner here, and it would be all internal. The angle we're talking about is this angle theta. How would we determine the length and the angle? If there's any inclarity or unclarity over here with this specific picture, we can visualize our problem again, except this time we can use dotted lines. We're looking at over here from this point to this point is a diagonal you can draw, but then you can cut it across right over here, and then you have a 90 degrees forming here, and you have an angle here. So what can we do over here with regards to representing all of this? If you look at this lower face over here or that lower face, and you know all of these sides here are S, that helps us out a lot. This lower face right here, you're looking at this diagonal going from one corner to the other corner. Well, that's a diagonal, and we have S and we have S, and we can determine this dimension which corresponds to that. You'll have S squared plus S squared is equal to C squared, the Pythagorean formula, and then C here is equal to 2S squared root S squared plus S squared is 2S squared, and then C is equal to S root 2, and that's exactly what you have coming out over here, S root 2. If you take out this triangle and you pluck it out, you have this side right here is S, and then this we've determined to be S root 2. Now this is all that remains to be determined from one corner of your cube to the other, and that's all we have to determine, and it shouldn't be hard. Use the Pythagorean formula again. S squared plus S root 2 whole square is equal to C square. You have S squared plus 2S squared is equal to C squared, and then C squared is equal to 3S squared, and then C is equal to S root 3, and that right here would be S root 3. Now let's determine the angle over here. One would conveniently claim that all of these angles should be 45 degrees, but that's not necessarily true. When you're looking at this lower face and you're looking here at a cube which is made of square faces, you know you have a 90 degrees here. When you're cutting it across, you have 45 and you have 45, and that's true. But for this long diagonal going from one corner to the other corner, this angle right here is not necessarily 45 degrees. It would seem like it is, but it isn't, and you can determine it. Cosine theta is equal to adjacent over hypotenuse S root 2 over S root 3, or you can say sine theta is equal to the opposite divided by the hypotenuse S root 3, or you can say tan theta is equal to the opposite divided by the adjacent S root 2. In each of these instances, you can do the inverse trigonometric calculation. Just take the trigonometric function on the other side. The s's cancel out very easily. You're really looking here based on the cosine. You're looking at a root 2 divided by root 3, and you inverse cosine it. You get 35.26 degrees, and that right there is your answer, 35.26 degrees. You can verify it with each of those functions over there. The trigonometric, you can do 1 divided by root 3, 1 divided by square root of 3, and inverse sine it, you'll get 35.26. You can also do this 1 divided by root 2, 1 divided by root 2, and you can do inverse tan, you'll have 35.26. So in all instances, this angle right here is 35.26, and that's your answer. And this is the length of the longest diagonal you can draw internally from one corner to the other corner. S root 3 is the answer. 35.26 is the degrees, the angle of that diagonal with respect to this other diagonal right here, this diagonal right here, and then the long diagonal, this angle right here, 35.26, and the question has been solved. And that's it for this particular video. Have a great day. Bye.